All right, workplace apprenticeship 30. This is number 6 in section 1.1. And so let's take a look at number 6 here. We're going to draw a graph here, and this is the table we're given. What does the question say about this? A type of dry fertilizer must be dissolved in water before being applied to plants. The fertilizer container shows the following mixture guidelines. So for 1 gallon of water, we need 0.42 ounces of fertilizer. So these measurements are commonly used in the U.S. We use liters a lot, and liters and liters, or milliliters maybe. So, but these are the units that they give us here. So 1 gallon is 0.42, 5 is 2.1, and 10 is 4.2. So it says draw a graph of this data here. So let's check to see if this is linear. We're going to plot these points, and we're going to check to see. Now, when you have a blank graph like this, you first of all have to decide which value goes on the bottom and which is going to go on the top. So which one, if you look at the numbers, which one looks like it's the dependent variable, the one that you would actually kind of measure? Yeah, the amount, well, see, look at the amounts of water here. The amounts of water, 1 gallon, 5 gallons, 10. It appears that they have chosen 1 gallon and then they've determined how many ounces of fertilizer go with it. You see that? They kind of like measure or calculate this. Based on this, they calculate this. So we're going to put the gallons on the horizontal, okay, as the independent. So let's just do that. You can just write, gallons or amount. Really, that's the units, gallons. So let's do amount of water, H2O. You can simplify. H2O is water, so you can write that if you want to do that. And then on this side then, amount of fertilizer. So amount of fertilizer. Okay? So just that we have that figured out. Now we need to do 1, 5, and 10 here. Okay, so that means this could be 0 if we want to start at 0. And then we have to kind of stretch this out as much as possible. We want to put 10 over here somewhere. So how many squares do I have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 11, 12, 13, 14, 15. I have 15 squares. Okay, so I can't make every gallon 2 squares because we'll run out of space. Right? If we do 1, don't write this down, but if I do this, you can see we're not going to get to 10. So I can't do that. Probably a good idea would be to use 1 square per gallon. I think that's reasonable. So let's write that out. 1, 2, 3, 4, and so on, all the way to 10. Okay, so that leaves us a little room on the right. That's great. And it uses up a big chunk of the graph for the data that we have. So that looks pretty good. Now what about fertilizer? So what about ounces? Now the smallest one, well, let's start at 0 here again, because we have a pretty small number. And then we have to go to beyond 4.2. So I'm thinking maybe 5 or 6 or something like that. We want to end up near the end. So how many squares do we have here again? Looks like looks like there's 15 up as well, right? So could I do 2 squares for every ounce? Do you know what you could do? This is an easy way of doing this. Do 15 squares, or do 4.2 ounces divided by the number of squares that you have. And this 0.28 means that if you wanted to use all those squares, each of these squares should be 0.28 ounces. That would use up everything. Now, 0.28 is not a very nice number, right? So you want to round that up, maybe. So to even 0.5, maybe. Okay? So let's go up to 0.5, which means that every 1 ounce here is going to be at every second square. That makes sense? And then what we'll see is we're going to have a lot extra, but we're using over half of the graph, so that's okay. We probably could have got away with 3, I think, right? Ounces per square, so yeah. But that's okay. All right, and we should put our units here on the side as well. Every graph should really have a title, too. And sometimes the title is given, sometimes it's not. But you could title it what the table is titled, I guess. Or you could say amount of water versus amount of fertilizer, or H2O. And versus is something that you can do on a graph usually, versus ounces of fertilizer. Something like that, just to kind of learn to spell. Okay, so kind of give it a little bit of a title would be a good idea too. All right, so now we're ready to plot some points. I'm going to put the points in red here. So at 1 gallon, we've got about 0.42. So 1 gallon, this is 0.5, so let's say 0.42 is right about there. And just kind of round it, do as best you can. At 5 gallons, we've got 2.1, so just beyond 2. And at 10 gallons, we've got 4.2. So we go over 10 and we go up 4.2. Okay. Does that make sense? Does that look right? Does that look good? So what we can do is we can kind of see right away whether this could be linear, and it looks like those 3 points are pretty close to being in a straight line, doesn't it? Looks like that forms a straight line. And you could check with a ruler or something. You can feel free to do that. Whoops, where's my shapes? Okay, so I'm just going to check here with my... Whoa, that's a really thick line. Definitely do not want it that thick. Okay, let's go thinner and make it green or something. Okay, so as you can see, let's see now, could I move that a bit? So it's kind of tough on this program to get this quite right, but it looks like we're pretty close, right? We're pretty close to going right through those points. Pretty close, you know? So it looks like it could be linear. You don't have to draw this line, but the second question says, does the graph show a direct linear relation? Now, if I was able to, I'll see if I can do it. If I was able to get this line to go right through these points, oh, come on now. Come on. There we go. Okay, does it look like it goes through the origin here? Yeah, it does. So is it a direct linear relation, yes or no? Remember, direct means that the line would kind of go back through the origin, through 0, 0. Yeah, so it does. It looks like, so you'd say yes, and then you would explain, right? A straight line through these points would travel through 0, 0. Okay, would travel through the origin. That would be your explanation. Okay, and then let's see, is there just part C? Yeah. So for part C here then, how much water is needed for 2.94 ounces of fertilizer? Whew, 2.94. Well, if we just go from the graph, 2.94, we're going to have to make an estimation, right? So this is where this line would come in handy. 2.94 would be, you'd have to make a careful guess. That's 2.5, so 2.94 would be pretty close to 3, so just under this line. Looks like it lands right on this line. You see that? Looks like it's exactly 7. See that? So using the graph, probably your best guess would be 7. And that's 7 gallons. Okay. Now we could make an equation for this. We could make an equation and find out that number from the equation, but I think we'll just use the graph because that's what it looks like this question is about, okay? So any questions about that? Does that make sense? Any part of that you need clarification on? Okay.